we have a sum and difference formula for sine and cosine, but what about tangent? So let's see if we can figure out some other way to express tangent of alpha plus beta. So we can't do anything with the plus in the middle because, I mean, we don't have a sum formula. That's what we're looking for. So I guess really the only thing we could start out by doing is rewriting this tangent out here. And so how do you rewrite tangent? Well, tangent is sine over cosine. So sine alpha plus beta over cosine alpha plus beta. Okay. But look, now we have sums inside of our sine and our cosine. So we can rewrite this using the addition formula for sine and for cosine. So in the numerator, we get the addition formula for sine, and that's sine alpha cosine beta plus cosine alpha sine beta. And in the denominator, the sum formula for cosine, and that's cosine alpha cosine beta minus sine alpha sine beta. So one thing about addition formulas is, I mean, how do you know when you're done? So tangent of alpha plus beta is given by this big mess, but somehow it feels like we haven't discovered anything new. It's somehow not useful. One thing that we might want is, since we are finding a sum formula for tangent, we might want tangents to show up. So how could we make some tangents show up? Well, to get tangent to show up, we're going to have to divide some sines by some cosines. If you look at the numerator, to get this sine alpha to be a tangent, we're going to have to divide it by cosine alpha, right, like this. But if we do that in the numerator, we have to do that in the denominator as well. And to get this sine beta to be a tangent, we're going to have to divide by cosine beta, like this. But if we do it in the numerator, we have to do it in the denominator as well. All right, that seems like an idea. Now we're going to have to distribute here and in the denominator as well. So for this upper left piece, we get sine alpha cosine beta times this fraction over on the right, and that's going to put this over cosine alpha cosine beta plus, and then this upper right piece, cosine alpha sine beta over the denominator, cosine alpha cosine beta, all over, and now we can distribute in the denominator. So this lower left piece is going to be cosine alpha cosine beta over the denominator that we're distributing, cosine alpha cosine beta, minus this lower right piece, sine alpha sine beta over cosine alpha cosine beta. And man, there's a lot that simplifies here. So in the upper left, these cosines cancel, and we get a tangent alpha plus, and then in the upper right, the cosine alphas simplify away, and we get a tangent beta over. In the lower left, everything simplifies, and we're just left with 1 minus. And then in the lower right, this is tangent alpha times tangent beta. All right, so there's an addition formula for tangent. If you run through the same argument, but starting with a negative of subtraction inside your tangent, this plus in the numerator turns into a minus, and this minus in the denominator turns into a plus. Okay, so there's an addition and subtraction formula for tangent. So let's see if we can use this. So let's find tangent of 13 pi over 12. So 13 pi over 12, it's not a nice angle, but as with so many of these angles that are over 12, some multiple of pi over 12, you can write 13 pi over 12 as a sum or difference of nice angles. So 13 pi over 12 is going to be, let's see, we could say 6 pi over 12 isn't going to be helpful. How about 3 pi over 12 plus 10 pi over 12? So this is tangent of 3 pi over 12 is pi over 4 plus 10 pi over 12, that's 5 pi over 6. And these are both nice angles, so let's use the addition formula for tangent. It was tangent of the first one, so tangent pi over 4, plus tangent of the second one, so tangent 5 pi over 6, all over 1 minus the product, so tangent of pi over 4 times tangent of 5 pi over 6. Okay, now we can evaluate these tangents. Tangent pi over 4, right? Remember your unit circle. So pi over 4 is like this. And remember, tangent is the slope of the terminal side, and that's slope 1. So 1 minus tangent 5 pi over 6, that's going to be like this. So it's going to be negative and small. And if you remember, the negative small value of tangent is 1 over root 3 over 1 minus tangent pi over 4, that's 1, times tangent 5 pi over 6, that's negative 1 over root 3. And I made a mistake here. This minus sign here should be a plus. Okay, so we get 1 minus 1 over root 3. Sorry, 1 plus 1 over root 3 over 1 minus 1 over root 3. Okay, it's okay as an answer, but we can clean this up. So to start with, we can multiply the numerator and denominator by the square root of 3, and that's going to give us root 3 plus 1 over root 3 minus 1. Already that's a little bit better. And then if you want to go one step further, you can rationalize the denominator by multiplying by root 3 plus 1 over root 3 plus 1. And that's going to give us, so in the numerator, root 3 times root 3 is 3. And then there's a plus root 3 and another plus root 3. So that's 2 root 3 and then plus 1. And then in the denominator, root 3 times root 3 is 3. And then there's a plus root 3 and a minus root 3. So those cancel. And then minus 1. So this is 4 plus 2 root 3 over 2. But then we can simplify even more. So this is 2 plus root 3. All right, so there's how you can use the addition formula for tangent.